Welcome everyone to is it May already? The May 2021 Columbus JavaScript user group, or ColumbusJS, as I keep trying to rebrand it, but keep saying it wrong every single time I kick it off. Tonight, we've got Chris Woodruff speaking on Electron. What's the full title of your talk, Chris?
I don't know. Desktop application for web developers.
Okay.
Yeah.
So that's going to be his talk this evening. Electron is a pretty cool stack of bits. The skinny of it, the TLDR is let you make web apps that are desktop apps, and you have used them and you may not know it. But before we get it kicked off, I just want to let everyone know how this works tonight. So if you're here on Zoom with us, just drop your questions in chat or go ahead and unmute and ask Chris. That's okay, right, Chris?
Yes, exactly.
I said it's okay, so now you have to say it's okay, right?
Yeah, no, it's great.
But the interaction's nice. If you're here in Zoom and you don't want to be on the Twitch stream, just hide your screen and it won't show up. Just hide your camera. If you're watching on Twitch, please leave your messages in chat there, or your questions in chat, and I will make sure that Chris gets them. And if you're watching on YouTube later, after I get around to finally editing this video and uploading it to YouTube, then leave some questions in the comments, and maybe Chris will see them or I'll see them and we'll answer them there. So, and with that, the floor is yours, Chris.
Okay, let me share my screen. Hopefully you can see my screen.
Looks great.
Okay. So let me give you a backstory of this talk. So I will admit that I have not done this talk in about 2.5, 3 years, and the reason is that I haven't really had a need to, because for me, I like to talk about things that I've been using or have used and have a passion around. And I did do some Electron back in the day, back around the second and third version of it. And so I kind of put this talk after a while, when I got a little bit away from when I was doing some Electron work for some consulting work. But then about 6 months ago, maybe 3 or 4 months ago, people were asking me about this, and I saw this need, and I saw people asking, how do we get these applications?
I believe your audio cut out, Chris.
Did it?
No, is it just me?
I don't know. Sounds fine over here.
And now it's back. Oh, that's weird.
Yeah,
Okay.
I heard him the whole time.
Okay.
I just got a message saying my internet connection is unstable.
Sorry about that. But
it's a good thing we're streaming it through Zoom and not from my my house.
Yeah, that's cool. That's cool. So just know that I'm getting back into this. This is the first time I've given this talk in quite a while, and it has been interesting to see what and how Electron has kind of grown up. There's still some flaws in it, and we'll talk about those, but I see it as a great way to, like I said, do desktop development by using those skills that we all have as web developers. So I mean, why do we need to create these desktop apps? So why not have everything in the browser? Why not think of everything as a Chromebook, and just everything can live in Chrome in a browser, and we can do everything? Well, I mean, I always say sometimes, and now with some of our browsers, you can go offline, but most people don't think of a browser as something that they would interact with offline. They mostly deal, and they think about applications that can be dealt with offline. Another one is they want to get to printers or other local hardware. They want to potentially like work with local files and edit that. And you know what, for some people, they still think of an application like a standalone application doing that and not a browser. So I mean, not saying that these are the only reasons why businesses think that they need desktop apps. Sometimes they want to have these applications that run on the local machine. Sometimes they want them to run in kiosks and without having very much else go with them. So sometimes it just feels better. I mean, how many people like Word or some of the Office applications as standalone apps compared to things in browsers? I hate Word and Excel and Outlook inside a browser. I just don't feel like they're a good experience for what I need them to be. Sometimes I just want applications that have a clear niche and I know what I'm doing with those. So sometimes it just feels better. And falls back to some people like to have desktop apps over internet web apps. If I had 5 different applications compared to 5 tabs in a browser, I can keep those 5 applications a little more organized, especially on the setup I have right now. I have 3 screens. I could probably get those more organized as desktop apps over tabs in a browser. So not to say these are the only, and they're not great reasons, because I think as time goes on, younger people that are coming up behind us, millennials and Gen Zs, they've only known to work in browsers. So maybe these reasons aren't good for them. So really, maybe this business need for desktop apps are just because me being a Gen X person grew up with desktop apps. So let's take some ideas. If we are going to do desktop applications and we're going to use Electron, which is a JavaScript kind of framework using Node to do these applications, what are some of the applications that we could use that I kind of take a look at? So communication apps, social media apps, and like Guy said earlier, you have worked with all these applications as Electron. In a little while, show some of the apps that I use every day or have used, and you'll go, oh, I use that app. Games. So haven't seen too many games with Electron, but they're starting to pop up now that certain CSS and JavaScript libraries are getting much more proficient or performant, so we can do these games inside a browser. Editors and reading apps, images and pictures, and audio and video conferencing. So if anyone uses Teams, I work at Quicken Loans. We use Teams. Teams is a Electron app. So the history of Electron, I'll quickly go through this. So Electron was actually started as an internal project at GitHub in January 2013. In May of 2014, it was open sourced because actually it came from Atom. So if anyone remembers that old editor Atom, it's still around. VS Code is clearly based on Atom also, but they separated out the application, Atom, from the framework and from the technology that they had developed it in. And they said, well, maybe other people can use the same technology to create applications like Atom that they need. So in April 2015, it was renamed to Electron. I don't remember what the original project name of it was called, but in 2015 it was renamed Electron. June of 2016, version 1.0 was released, and as of this month we are up to 12.0.7. And just to show you how quickly Electron has grown, the last time I gave this talk, the current version on this slide was 3 point something. So in a matter of 2.5 to 3 years, we have gone from version 3 to version 12. And actually right now, if you take a look at the current versions, there is betas for version 13 out there. So version 13 has almost 20 different betas that they've released. So it should be, 13 should be coming out pretty soon. So before we dig into building Electron app, we need to know about the building blocks for it. And so really the building block is HTML5. It's just a HTML app, CSS. That's what is going to be used in what we call the renderer. There's two processes that we will be looking at. There's a main process, and that is for the frame around the application. But then what's inside is that the actual web application that we will be hosting inside the Electron app. So we have the main, and then we have all this HTML and CSS that we will use. And we will use JavaScript in terms of JavaScript, TypeScript, but also Node. And the last is that we're going to use the Electron Framework. The Electron Framework is based, it's built with Node, and the core features are web standard. So anything that you can build with HTML, CSS, and JavaScript, you can host inside inside Electron frame, as I call it. You can do, so that means we can do Angular, we can do React, we can do Vue, but we can also now do, people are using Electron with Blazor. So from the .NET world, I do a lot of .NET stuff. And from there, we have Blazor, which is a lot around the web assemblies. So even WebAssembly applications can be hosted inside Electron. So file system, we get access to the file system that the Electron app is on by using the Node.js APIs. All major OS platforms can be used, Windows, Linux, Mac OS. There is still some, even a couple years ago when the last time I was doing this talk around the community, there was experiments around iOS. I don't think it's really gone anywhere, but there are some experimental kind of technologies to leverage Electron for iOS, but I don't think that's really progressed that much in the last couple of years. And then we have native OS features like we can do menus, we can do dialogues, we can do notifications, and I'll show some demos that we can do all three of those. They're pretty simple, and we'll just talk about when to do them and when not to do them, especially dialogues. So native installers uses the whole npm ecosystem. Auto updates, if you use Squirrel, it uses Squirrel. We'll take a look at the packaging and everything. I'm not going to demo Squirrel, but just know that there is, beyond this talk, there is ways that we can do auto updates where the application will know where to look for any updates, and you can auto update your application from an on-premise location or from across the internet. So analytics reporting, basically you can leverage Google Analytics or any other analytics technology inside your application, and it will report back and you can get your findings. And then debugging. So all the goodness that you expect from debugging in Chrome, because Electron is basically Chrome. And what's inside Electron? Inside Electron is Node.js, is Chromium. So the open source technology for the Chrome browser is what you're actually building. So when you build Electron app, you're basically housing an application inside a browser that has nothing shown. It's basically a Chromeless, if I say a Chromeless browser that just houses a web application. And in the end, the V8 engine, which is the engine that your JavaScript interacts with. So that's really what's inside the Electron, and what the Electron framework kind of hides away from you and exposes through the all the Electron APIs that we have access to. So there are two sides of Electron. We do have, like I said in the beginning, a main process. So this is, main is what you can think of as the Chromeless kind of frame around your application. It's the Chromium that gives you the window itself. And in there, we have access to the Node.js APIs. We have access to the Electron APIs. And then we have access to what we call IPC. So that's inter-process communication. So this is how we can communicate and work with outside resources. So in the case of an open dialogue, if I'm opening a file, the main application has the menu for your application. It has the menu item for opening, getting an open dialogue, open file dialogue. When that open file dialogue has one or more files selected, you can then send that location of those files over to what we call the renderer. So think of the renderer as the web page. That's the process of the actual application that's running inside the Chromeless browser. So we have the ability to also do IPC from the renderer. We have the whole working with the DOM, and we also have access to the Electron APIs and the Node.js APIs. So what we really are doing is we are having this two-process type of interchange that we can create the render from the main. So the main starts up and it stands itself up, and then it says, okay, now we're going to render the web application that this Electron app will host, and then we can communicate back and forth. So if I had 2 web pages, as we can show, we can have multiple windows open, what we call browser windows. And the only way to communicate between 2 browser windows is to send a message back to the main process, which then will send that to wherever it needs to go in another window potentially. So think of it as if I had a main window and a setting window, and I had to send something from setting back to the main, I would have to go through back to the main web page. I would have to go through the main process to send that data through IPC. So it's a little harder to communicate than it is to really show, but we'll show a demo in a little bit. So again, the main app can generate multiple render, which are the visible web pages or the visible application windows that we can see in Electron app. I will say, be careful of generating multiple of these renderers. What you have to remember is that each one of these processes, and these are all different processes, each one of these processes brings along an instance of Chromium and the V8 engine and other things, any of the code and HTML and JavaScript that they need to run, but especially the Chromium. If anyone has seen how much memory an instance of when they open Chrome, and then you start opening up those tabs, you can see that the memory goes up pretty quickly. And if anyone remembers Slack, there was a big problem with Slack years ago before they architected it differently, to where Slack was, at one point, I had an instance of Slack that was basically using about 12 gigs of actual memory on my 16 gig machine. It's because each Slack group that I belong to was rendered in its own render process. So say I had 20 Slack groups that my Slack app would allow me access to. I had actually 21 instances of Chromium up at any one time, which is a lot of memory. So they've changed it. So just try to keep it to one render process. That will keep your memory down. So let's do some demos. I know people are like, I don't want to see slides anymore. So hopefully you guys can see my screen. Everyone see my ID?
Excuse me, Chris. Can you have multiple windows from a single renderer?
You can't have, so each renderer is its own window.
Okay.
Yeah. So think of it as, if I want a new window, if I had a Electron app that needed to show 2 distinct windows, those would be, each would be a renderer process, and each would have its own instance of Chromium and the V8 engine that would have to be initialized, stood up, and running to have that. That's why you don't see a lot of Electron apps that have multiple windows, because there's just basically your memory constraint is going to go up and up. That's why I always go back to like VS Code. VS Code doesn't really show any second or third windows, and it's because they're trying to keep down their memory footprint. So let's take a look at a simple basic Electron application. So there we have a main. So basically, all you really need is a main and an index. Now, you can have package because you need some properties to go along with, like the name and the version and other things. You don't even really need any dependencies in your package, because the application will pick that up. But I like to have explicit dependencies, so I at least know what version of Electron I'm working on. So minimum, you need a main.js, you need an index.html just to show something for the renderer process, and then you need kind of this package.json. If I take a look at the index, it's a very simple HTML file, nothing special. I am going to show on all my demos, I go out and go into the process and show what version of Node and Chrome and Electron I'm working at. That way, it's just a few things I show in my app. But if we take a look at the main JavaScript file, it's pretty simple. We're creating two objects, one for the application and one for the browser window. So you can think of the app as the application, which is kind of the main process. And then this browser window is going to be the first renderer process. And I'm going to create that main window. What I call main window is going to just be based off of that browser window, and I have to give some information about it. So I gave it 800 width, 600 height, and then I need to tell that window that I want it to have Node integration, and then I need to turn off the context isolation. To be honest, I am trying to figure out why I have to do this. When I ran all my demos over the weekend that I hadn't touched in a couple of years, a lot of them failed, and I had to figure out why. And it was because now we need to turn off this context isolation, which I need to kind of dig in and figure out. So that's why I'm saying you guys are kind of my guinea pigs. Now in here, I can also do this preload. I can tell the window that I want.
Sorry. Can you define what context isolation is?
That's what I was. So context isolation is, and I'm trying to remember it. I did look it up. It is, shoot. I don't, right now, I cannot remember. Bear with me. I apologize for that. That is, I'm embarrassed that I don't know. I can't remember what that setting is. So forgive me.
No problem.
So, but I can, what's that?
Oh, I was just saying, no worries.
Okay. So in here, I can also do a preload. So I can tell this window before it loads to go out and run this JavaScript file. Right now, there's nothing in there, but if you had to do anything before the window loaded up, you could. So I just put that in there because just to remind myself that I do have the capability to have that. In here, all I really have to do to show my application is to load a file. So for this example, I'm just loading in the index.html. If this was an Angular or a React application, I would just have to point to that initial file that would kick off the application for either one of those frameworks. And then in this case, I'm also setting an event. So I'm saying that when the main window has its closed event fired, I'm going to set the main window to null. That way I'm cleaning up that memory and I'm not letting this window, all the resources for this window stay around in memory. So just by setting it null, it will free up that that main window, and then the app can shut down. And then we want to deal with the main application, so the main process. So that's where this app comes in, and when the app is ready, it will create the main window. It will on the activate event, it will and get all windows and unresolved. So I don't even think I need, why is that? I don't even know why that's there. So like I said, wow. So, and then if I had this window all closed, it will, I need to do something special when I want to shut down the application when I'm working on iOS or on Mac OS, which is Darwin. It's signified as a platform of type Darwin. In here, if it is running on Mac OS, I actually need to call the quit method for the main process, the app. For Windows and Linux, I don't need to do that. Electron will shut down gracefully for both of those operating systems, but for Mac OS, I actually have to call the quit method explicitly. So if I run this, let me go out and run this, and then I'll bring it over into the screen. So let me pull this over. So when I run it, this is what I get. So this is the very basic Electron application. So I get a generic menu. If you don't explicitly design a menu, this is the menu that you get. You get a pre-designed by default menu. So I can exit. I have initially the function that we usually get with edit, view. We can see that we can open up and take a look at the Chrome developer tools. So in here, I get everything just like I do in a regular normal Chrome browser. I can take a look at the network traffic. I can see the sources. You can see that it's just giving me the index file. So this proves that really this is just a Chromeless Chrome browser that we are working with. And that's all you really need to open up and do Electron. It's not very hard. Now, throughout the other demos that I'm going to do, we'll show how we kind of build on top of this basic one and to do menus and some other things like events and stuff like that. But let's go back to, I'm going to go back to my talk. To install Electron, all you really need to do is just install the npm package. So I always install it globally. That way, I really don't want to pull it into each explicitly to each one of my web projects. I just want to have it installed globally. The structure that I need, like I said, all you really need is a package.json. You need the main, the JavaScript file for the main process, and then you need at least one HTML file or something to be visualized in the browser window. And that's really all that you need. And basically, the only three properties you need in the package.json is the name, the version, and then you need to tell it where the main the JavaScript file that's gonna that needs to run initially for the main process. So that's why I always call it main.js, because it has a property called main, and it needs to know where to kind of kick off everything. And then the main.js, you just need a lot of that code that I showed before. And then the index is just, I just showed that too, but it's just really going out, and like I said, I don't really have anything special, but I do show the version of the of each one of the frameworks I'm using, the Node, Chrome, and Electron. So execution is just in the directory that you want to run and test out your Electron project. All you have to do is electron dot, and it will go out and find that package.json, which will then tell it what the main process JavaScript file is, and you're off and running. So it's as easy as that. There is some additional parameters that you can do for if you want to run in debug mode, because I will say the Chrome tools, the Chrome developer tools, will not give you access to debug the main process JavaScript file. So if you ever want to debug that, you'll have to set up either like VS Code if you use that, or I use WebStorm. You can set either one of those tools or whatever IDE up that you want to then to allow you to step through the that main.js file that I showed you. But if you want to just debug the application, your actual hosted application, you just do that through the Chrome developer tools. And then packaging you can use, and years ago when I did this talk, I used to do Electron-Packager. It was a tool that basically would collect all of the information about your Electron app and bundle it and build it as an exe. And there are some parameters that you can set, so you can tell it what kind of platform that you're trying to build it for. So you can build different platforms from different OSs. Like I could build a Linux application from Windows. I can't really build a Mac OS from Windows or Linux because of the way that you compile. You have to have a lot of resources from Mac OS. But in this case, I'm going to build a Windows application. I'm going to have it as 64-bit. I'm going to push it out to a folder that I'm going to call dist, D-I-S-T. And I can also say I'm going to, every time I'm going to package this, it's going to override any files that are out there. And then you can give this last one prune. Prune will go through and tell Electron Packager to try to prune and try to find unneeded modules. So if you didn't use prune, basically if you had dependencies that you weren't using, if you had any modules inside your project that you didn't remove, then that would increase the size of your EXEs. So by doing this prune, it at least tries to go through and find all the packages that it doesn't need, or any of the modules that it doesn't need. Now today we have this new app. It's kind of like a application or well, I'll say it's a command line application called Electron Forge. And Electron Forge kind of wraps around the Electron Packager and adds a lot of additional things onto the packaging. So it will build in Squirrel natively, so that if you set it up correctly, you can do auto updates. So all you really have to do with this is just to install the Electron Forge /CLI module. Then in your directory, you do an npx to import that Electron Forge, and then you just have to say npm run make inside the web application main folder. And what that will do, I'll show you a demo that in a little bit. What that will do is it will basically figure out everything that the application needs in terms of OS, and it'll try to match up whatever OS that you're running. If it's Windows, 32-bit, 64-bit, it will match up by default. If you don't give any other configuration, it will say, I'm building this application that matches the OS that I am running on at this point. Electron's built with, or applications built with Electron, GitHub desktop. That's a Electron. I used to write books. There used to be an editor for GitBook that I used a lot, so I had that in this list. Tweetin. So Tweetin is a Twitter application that I use all the time. That's Electron. Yeoman app. Basecamp. Let's see what a Postman. If you use Postman, that's an Electron app. WordPress app. Slack. Slack is still Electron. Visual Studio Code, and the original Electron app, the Atom editor. So basically that's a little sampling. If there is a list, if you go out to the Electron site, there are about 2,000 different applications in their catalog that you can look up and find everything from book readers to development apps to music apps, all the way down to, I think there's a couple games that they do have in their catalog that they point to. So let's take a look at the rest of the demos quickly. So I'm gonna get rid of this, and the next demo I'm gonna do is events. This one I'm not gonna run because it doesn't really do anything special. I'm just showing you that all the different events that you can set up, that you can interact with. So you can interact with if the main window, now the main window, remember, is the browser window, which is the render process. So if that main window goes unresponsive, the main event will fire off on that inside this main process that you can react to. So if it goes unresponsive, maybe it something happened, you can try to figure out what is going on. If nothing else, you could log something to somewhere to know some of the reasons why. Or maybe when it responds back from being unresponsive, then you can do something. You can catch any uncaught exceptions. You can do the typical stuff: maximize, minimize, restore, resize, enter full size screen, leave full size screen. And there's a few other events also, but I just wanted to show that there are a lot of events that the main process can react to based on those events coming from the actual render visible window. If more interesting is the menu. So if I show a menu, and let me run this, I'm going to run this this application first. You saw the default menu. Now if I run this application, you'll see that there's an entirely different menu here. I have a very simple menu just with a number of a few different menu items. I do have this dev tools, which I can open and close. And then I have this settings. So as you can see, if I drag this thing, I have another window open up. So for the person that said, can you have more than one, or can a render generate another render? It looks like it does, because this menu is coming off of the main window. But remember, this actual menu is being driven from the main process. So this menu actually lives outside of what is in this Chromeless browser. And when you're saying you want another, when you want to show the settings, you're actually having the main create that setting window. And this is what it is. I have the same menu set to this. But remember, this is actually, right now I have 3 instances of Chromium and the V8 engine running right now. One for each one of these and one for the main. So that's why I always tell people, if you can build your application only to have one visible window, then you will be kind of building your Electron app the best way. So let's take a look at how we build these menus. Basically, these menus are built just by setting it up through a very simple method, just a bunch of properties and setting some additional properties. So I have my label, my main label is menu. I have a sub menu. one submenu for the whole thing. I go through and I do a label for each one of these. I can give an accelerator, which will tell me the key stroke for that menu item. And then the role is, if there is a predefined role, like undo is a predefined role that will fire off an event in the main window. This open in here, I can fire off a click event, which will show an open dialog. I forgot to show that. If I show it again, I can show what the open does. Basically, open will, and it's always showing off the other screen, it will show an open dialog where I can come in and pick files, and or I can select a folder, and it doesn't really do anything because I'm not actually sending that data back to the window, but I could coming off of this. So, and then I have setting. So in here, I can, on the click event, I'm going to set up a number of parameters about the open dialog that I want. I can give the size of it. I can say if it's resizable. Many things that you can do if you come from the Windows world of doing VB6, a lot of those same properties. And then I'm going to do a setting window, and I'm going to say, and remember, this is all in the main process. So I'm going to create another window based on the browser window with those parameters, and then I'm going to set whatever is inside that. So I just set it to settings.html, and it renders that new window, which again is a Chromeless browser, and it will show it, and I have two windows open at that point. And then if you want to do open and close the DevTools, you can just do these Electron APIs, which are from the main window. You can say open DevTools and close DevTools, and that will open and close, showing you the Chrome DevTools. Now, for this menu is what will be used for Windows and Linux, but because we all know on Mac OS, the menu system can be different and usually is a different menu system. You can set that up in a entirely different way by setting if the process of the application that you're running on is Mac OS, then it will fall down to this configuration for your menu and run this and show this. So you can actually have one file that potentially could, well, actually it doesn't, because this was compiled for Windows. But if you ran this application without packaging it, and you ran this code on Mac OS, it would show this other menu system. So just know that you can do that. So you can have, you can kind of have one code base and then package it up for different OSs, and the code itself will work fine. So, but that's how you do menus. DevTools, we've already looked at that. Notifications, this is kind of interesting. Let me run notifications. How much time do we have left, Guy?
As much as you need. We don't have a strict schedule.
Okay.
I mean, don't go for 2 hours, but you know.
Oh, I'm not going to, trust me. Trust me, so, and I'm not on the main screen, but if you heard that sound, if you did hear my system sound, what happened was I have two notifications showing. And why you can't see it is I'm showing everything on my second monitor, and those notifications are showing on my main monitor. So kind of defeats the purpose. But in here, I can, if I come down.
Hey, Chris, when you say notifications, are those like the operating system
Yes.
notifications, like the little thing in Windows and the notifications?
Exactly. So in Windows, it will show down in the right hand section of your main window. In Mac OS. In Mac OS, it'll show up. I think it comes over in the top right.
Yep.
Is that correct?
That's right.
I am not a.
Yeah.
I'm not an Apple.
Yes.
Yeah. So I'm not an Apple. I'm not a Mac OS guy. I'm a iOS guy, and then iOS, it would, if you built this for iOS, it would show a notification for iOS. But in here, I have you can do notifications from the main process and the renderer process. So I can set up a object called notification that has my title and my body, and then I can send that into a notification and show it. And what this will do is this will fire off right away when my application starts up. So just know that you can do notifications from your main OS. And if I did render.js, I can, so this is if I go out to my index.html, I am referencing this rendered JavaScript file from the simple HTML file. And if I jump in there, what this is going to do is it will fire off a notification when my window, when my this visible window gets created, and when that HTML gets processed. So if you went out to my demos, which all my demos are out on GitHub, and you ran this notification, you would get the main process notification first. Then you would get a second one coming from the renderer process. So, and you can have these fire off whenever you want to. So there is that way for notifications. And to go back, and when I said dialogues are like what I am doing with like this system with my settings little window. You can have dialogues. I would recommend doing dialogues inside your application. Have those dialogues that don't actually create a additional window. So that's why I always like to, and I recommend building your Electron hosting app, the hosted application, to just open up those modal dialogues that you can do inside the application itself. Let's see. Oh, IPC. This is a interesting demo. So let's take a look at how we kind of send information back and forth. And I will first just show the application itself. So I do have two windows for this because I want to show what is going on, and I'm going to show my so you can see right now I ran this, and I'll put this up here. I ran this application, and in the command it's showing a hello from main window on start. So that is a event that gets fired that I'm just showing that. But if I send a additional, let me move this out so it's not covered. I can send messages that will just show because I'm just logging them to the console. And I can do that. I can do the same thing from the remote window. And these are messages coming from each one of these windows back to the main process, which then gets pushed out. And I could do anything with them, including sending message to, I'm sending a message from this larger window to this smaller window. So that's why this pop-up shows up, because I am, and I'll show you this in the code, I'm actually sending a message from this larger renderer, the larger resolution renderer process, goes back to the main process and then gets sent over to this IPC remote window, and that will show the message coming over. As you can see from the console, I have the Chrome window tools opened up. So if I send that over, it will say message from main window came over. So there's been 2 of them so far. But let's take a look at the code on how to do this, because it's actually not very hard either. Everything with Electron has gotten really easy to work with. It's pretty logical. So in my oh, that's notifications. So let's go down to IPC. In my main, I do have a lot of the boilerplate stuff that I do in the menu. So if I come down to here, I have the ability to send asynchronous messages and synchronous messages. But so on this IPC main, what I am doing is if I get a message that matches up with the event that is created, then I'll do something with it. So, so with this IPC main, I could send messages to it, or I could get back some and receive some messages. So, and I can create my own events so that I know what events are coming over from different windows and different kind of the business logic that's coming over from another window. So in this case, I have a request update label in remote window. If I go out to index, which is my larger window, I have an internal script. And in here, I am going to send, so this IPC renderer is the object that is inside the renderer process. And in here, I'm going to initially, when I create my main window, this message will get sent over to the main window because it just gets fired right away. But I have these other things like send message to remote window, and then I do have some listening stuff. But in here, if you remember those 2 buttons, I had a send message and a send message to remote window. These are what I am firing off when in each one of those click events. So down here for each one of those buttons, I have an on click, and it's just calling back into one of those JavaScript messages to send something either send a message back to the main window, to the main process to just be handled, or this other one, which is a message that would be sent to the main window. As you can see here, this request update label in remote window matches up with this listener, this event on my IPC main process, and that will then send a message to action update label, which if I went out to my second window logic, you would see that it has a action update label, and I'm just kicking off an alert that says receive message from main window. So, and then it just kicks out whatever was sent over into the console. So this is how you send information. If you do have, you can send information from your main and your render process back and forth, but you can also send information if you do have two render windows open at one time, and they have to share information back and forth. Anyone have questions on that? Hopefully I explained that well enough. And then testing, I'm going to skip over that for time reasons, and I want to go into packaging. So the packaging, I'm actually just going to come in here and show what we can do. So let me go back out, and that is CD07. So let's just run this. Oh. Just to show that it does run. You want to always make sure your Electron app runs and runs well, and you've tested it before you package it up. So as you can see, I have everything kind of working on this. I can open up a setting window. I can turn on and off. I can open and close my dev tools. So let's package this up now. And like I said, I want to, if we go back and show how we can do this, it's just as easy as npm run make. So let me go back to my thing, and I'm going to do a npm run make. And what this is doing, it fires off the Electron Forge. It checks your system to see what the operating system is. It tells you what it's building. So for this, it's using a 64-bit architecture. We are going to make using Squirrel, so it will be having this auto updating capability if you want that. It's turned on automatically. So this is using Windows and 64-bit Windows exactly. So it takes a second to build up. So let me go out and get a File Explorer. It's done. As you can see, it's completed. If I go out to packaging, you'll have this out folder. And then if I take a look at the Electron packaging demo, I have this Electron packaging demo.exe because it basically takes the name from your package.js. You can see that this executable is 128 megs in size. So basically what the packager and what Electron is doing is it brings everything that this web application needs, in addition to all of the Electron applications and modules and libraries. So it can get pretty big, and that's why there's a few things, and we'll talk about that in a sec, what you need to remember before you package this up. But if I run this, there's my application again. It gives me, and it keeps showing on my main monitor for some reason, but it does allow me to open up a setting. It lets me open up DevTools. So even inside the Electron app that's fully compiled, I still get all of the capabilities and all of the Chrome DevTools features. So I would actually probably not allow your end users, once it's packaged up, the ability to open up the Chrome DevTools, but I do it just to show that you still get everything in here. So it proves that this is still just a Chromeless Chrome browser, even if it's in an exe format. And so you have all this and it comes with Squirrel, like I said. So Electron will use the Squirrel exe to see if there's any updates wherever it's configured to go look for updated applications. So that's kind of nice that it will auto update, just like a lot of the Electron apps that you work with every day will have the ability to discover updates and auto update themselves. So let's get rid of that. Let's just keep going. There's a few things that before we get done, some performance reminders that you have to remember when you're building Electron app is don't use unnecessary modules. I mean, we're all guilty of thinking or using some modules or installing npm packages inside of our projects and then forgetting about them and going, oh, it's no big deal. I'm not using it, but it's not going to hurt anything. Well, it does hurt something in Electron. It's by having all these unnecessary modules, if you're not doing any pruning, or if the pruner of the Electron packager can't discover that module is unnecessary, it will include that module inside the package that it creates. So the size of your exe will increase unnecessarily. The other thing is don't run code too soon. Don't run code that doesn't need to be run in the beginning. So if you come from the Windows, and I'm an old time Windows person, kind of why we had to have, we were running, good or for bad, we used to run a lot of code in the beginning. And so our applications took a while. I don't know about you, but I remember getting up for coffee with some applications I had to run because it took them so long to start up. But just be aware, don't run code too soon. Don't block the main process. So kind of inspect all your code execution at runtime. And then don't block your render process also. Kind of leverage the features of Chrome. And you can do two things to help out not blocking your renderer process. That is, you can use a API called request idle callback. So basically what that will do is if you have to have something run, you can throw it into the queue that will wait until you get some idle cycles, and then it will execute that code. So that will help not to kind of block the render process. The other one is to use web workers to run code on separate threads, and also if you are going to use IPC, try to always use asynchronous messages. Don't use synchronous, because the synchronous will potentially cause your processes to stop, because they're waiting for those calls and those messages to be rendered in a synchronous manner. Bundle your code in as few of files. So for this, I would say, like if you don't put all your code for your main process inside one file, if you have a renderer, try to minimize the number of JavaScript files that you have for the renderer process. If you can get away with one, with just a render.js, and you can keep all your code in one file for that window that you're running, it will Electron will run kind of more performant because of that. And then I always say, like I've said a number of times, use a single browser window. And if you're going to use other windows, other render windows, besides the main one that you're using all the time, keep those as short of a life as you can. So I would not advise you to build applications that have 2 or 3 or 4 windows open at the same time, because remember, you're dragging around a instance of Chromium and the V8 engine for each one of those windows, which the memory footprint will increase dramatically with each window that you render. Oh, and then the last one is don't fetch data from APIs. I mean, this just goes common sense for all applications. If you're calling data that doesn't change often, it's going to impact the performance of your application because of the latency of those API calls. So just remember not to fetch data that you don't need to. If it is data that doesn't change often, maybe you can bring that into the application itself and save yourself the latency, unless it's going to impact the size. A large data set that's going to impact the size of the executable, then don't do that. But just be smart about fetching data from those APIs that feed into your web application that gets hosted inside your Electron application. So the resources are all out on the demos that I've shown, are all out on my GitHub, which is just C Woodruff, and you can find those out under the repo Electron_demos. And that is it. So I appreciate everything. I went a little bit over that, I thought, an hour and a half. So hopefully everything was okay. And if you guys have any questions, let me know. And Guy, do you want me to stop sharing?
Well, let's see if there's any questions. It might make sense
Sure.
to show your screen if there's questions.
Yeah,
They
you're
may
right.
want to see code to go with them. So
Was there any questions from Twitch?
No, there wasn't. We had 2
I'm-
viewers.
I've got a couple of questions.
Sure.
So if you were writing an Electron app for non-programmers to use, how buggy are the installations for like non-programmers to use? And also with the Squirrel updates, they tend to be pretty much error-free, or they tend to have issues? And then second, if I were going to do something like this, I'd see where I'd like to deploy to 2 targets. One target being just a website, and then the second target being an Electron app for people that want to run stuff locally, like if they're having network issues or whatever. Obviously, some of the interface would be different, but a lot of it would be the same. So, and then thirdly, testing. I could see where it might be convenient to do automated testing of your Electron app, maybe as a web page, for testing, and then you bundle it into Electron at the end. So those 3 things.
Yeah. So let's take a step back. So I would never develop the hosted web application directly inside Electron. I would always, like you said, I would always run it, test it as a standalone application, web application, which then I would take and house inside Electron, which if you take a look at like Postman, that's what Postman does. Postman runs exactly the same inside of a browser as it does inside of its standalone application, because it's the same app. We're just taking that web app that they created for browser experience and then put it into the hosted Electron. So yes, so I would test it, make sure everything runs well. Now there are some things that you have to do once you get it inside your Electron application. So you have to be able to work with the menu system that you set up. So your application needs to be able to react to like all of the edit functionality, the copy, paste, cut, undo, redo. If you build those into your menu system, it needs to be able to, if you open files, so say Postman has files that feed into the HTTP requests, you need to be able to change your application itself to allow it to get that information from that main process when it's sending those messages back to the that IPC render process. So there are a few changes that you have to do based on the interaction between the web application and the Electron wrapper around it.
Mm-hmm.
But yeah, you can call this Electron Forge. That can be called from within your CI/CD pipeline. Did that answer your questions?
Yeah. What about the bugginess of the installation and the updates? Is that not buggy, or?
Yeah, I haven't. I've used Squirrel in the past, and my users never really had an issue with it, as long as their internet connection was a decent. I mean, if they had a really slow internet connection, that's going to impact the kind of their experience with auto updates. But with Squirrel, you can have it auto update or give them a notification if they want to update it. So if you do start it up and you don't want the application to update right then, you can present that to the user for a yes or no indication, and then you can do it the next time the application starts up.
Mhm.
But no,
Thanks.
I haven't found that Squirrel's pretty good. I mean, basically, all it really is downloading that new package someplace and then replacing. You're just basically having that squirrel.exe basically overwrite all of the files that from one remote location to the local file system that you're on.
Thanks.
Yeah.
I have a question.
Yeah.
So I don't know how important this is, because the two examples that I was thinking of, you demonstrated how to do them without this, but I'm curious if there's any way to inject like native code if you need to do something lower level, or maybe if you need to have like a specific layout or something that's you know, not in a browser. Is there
Okay.
any way to do that, or is that like kind of a sign you should be using like the Chrome embedded, whatever that, I think it's Ceph, the Chrome embedded framework, or some other cross-platform thing?
Yeah. That's a good question. I haven't really dug into injecting code during a real time. I don't know if that is, to be honest, I don't know if that is, if Electron is capable of that or not. I mean, basically what you're getting on the inside of that exe is a bundle of all of the files. So you might be able to. I don't know for sure, but
I actually
say-
did some digging into that very topic while you were presenting.
okay.
And there are ways to do that.
Oh, cool.
You can, like on Windows land, you can load DLLs and stuff like that, but there's some odd gotchas. And so it's a little brittle was the sort of the summary of doing that.
I know there's like ways, like if you're in Node, you can call native code, right? So I don't know. I guess you could use IPC or something.
There's a
Yeah.
restriction on how there's like I think this is what that content aware flag we were looking at the very beginning of the talk was about.
Context information.
Or it might be related to that, because there's a limitation on the way Node and browsers will load like DLLs and stuff like that, where if it's loaded by one process, it then can't be loaded by another. Like it's got an odd restriction that's causes some problems that the Electron team worked around that, but it still leads to a couple of open issues that haven't been resolved yet. I actually was at the GitHub.
Yeah.
I went to the GitHub page and it was like the pinned issue at the top because people ask you that question all the time, Noel.
Oh,
Cool. Thanks, guys.
So it was at github.com just for
that
reference.
question. I'll at least get some of those details. So either I'll put it into the updated version of this talk, or else know more about it. So
Here, I'll post the link here in chat.
cool. Thanks.
There we go.
But well, I appreciate you guys being my guinea pig, kind of. So
Matthew has a
question.
sure.
My question was, so like for translation, if I'm like translating a web app and I have it's pretty straightforward to use a JavaScript library to do translations. But if I want to translate the menus in Electron app, am I still using the same, like a JavaScript translation engine, or do we use POTX files, like the standard translation, localization, locale files that applications use?
So can you store your menu externally in a config file and then pull those in? I don't see why not. I haven't done it, but I don't see why you couldn't do it, as long as those configuration files get bundled and get pulled into your, like during the packaging stage. As long as they're referenced by the main, that main.js. So it would be included when your Electron packager gets run. So I think you could, so you could have kind of, you could have a dynamic, I don't know if you could do dynamic menus. So once your menu is created for your main process, I think you're pretty much set with your menu system.
Right. So like when you launch an application on a different locale, so let's say ENUS is the
locale.
English, and then
Yeah.
you have say or Chinese or simplified Chinese. You know, the Windows application or the Linux application is going to know the locale and
Sure.
to load. So that was what my question
Yeah.
was.
Yeah. I think, you can do that. There is internationalization and localization in Electron. So yes. So now I understand what you're saying. You want to, based on the locale discovered by Node, by the Electron API, the Electron file system, then to bring in those specialized text labels and bring them in. Yeah, you can do that. I've actually never done it with Electron because I've never had to do localization, but you can do that.
I have
And
one more question if someone else
Sure.
doesn't have another question. You mentioned that you should use as few files as possible when you're loading your render index.html or
Yep.
JavaScript application. Does that still apply? Like we have, the technique of using JavaScript modules. So when you in your index.html, you can put a script tag that has type equals module, and that invokes kind of Chrome's modules. Does that have any less of an impact using modules?
No, I don't think so, and I don't believe so. My thing is you just have to remember that every window is an instance of Chromium. That's where Slack got into trouble and other applications got into trouble years ago, is when they were building their application and it was easy for them just to, hey, for each Slack group that you belong to, create a new render process because each process can handle things on its own. And then when you got up to a couple dozen of these Slack groups that would be generated inside the main window, it was funny to go into like the task manager in Windows and take a look at Slack, because you would see the slack.exe and then you could expand it to see inside of it, and you would see like basically like I could get 24 or 25 different sub processes in there, each one having its own Chromium, which, like I said, I could get Slack to basically almost take down my machine because it was using so much memory after a while. So that's why I said that it's more about, like I always say, if you're going to build an app that's going to be hosted by inside Electron, use like a SPA, or use something that you're going to kind of have that dialogue experience inside the application itself. Kind of like what VS Code does. VS Code or other applications, if they're going to show a setting dialogue, they set it up inside the web application as a modal dialogue, instead of presenting a new a real new window that is external from that main renderer window.
Yeah, I think your explanation helps a little bit. It's a little different from what my meaning of loading JavaScript modules is.
Yeah.
If a
So-
single page
so I
application
don't
like
think that
Angular,
loading all these modules really impacts it, because you're only packaging that module up once. Now you might be loading it multiple times, but it won't impact the size. I don't think it'll impact the size of the exe, but I don't think it will impact the memory constraints as much as other gotchas.
right? I mean, so like if you're suggesting using a single page application or SPA, then Angular and React, they have differential loading. Webpack and Snowpack do bundling, and so that's still kind of recommended if you're recommending that.
Yeah. Yep. I really recommend, like, I'm building Electron app, but I'm building a web app that will go out to a baseball stats API that I'm also building on the back end. I've got a database with baseball stats from 1873 until last year. I'm going to build an API that sits on top of that, and I want to build a web app that consumes that API, and then I'm going to wrap that app or that web app into an Electron app. And I'm going to do that as I haven't decided if I'm going to use Angular or React. It's probably whatever I kind of want to dig into deeper, but whatever it is, it's going to be a single page. I'm going to set it up and do it as a single page application because of just how I like to architect and how I've architected the previous Electron apps, and kind of trying to keep down that memory constraint. So yes. So I like just to have one app and keep it simple.
So we got a comment from Twitch.
Okay.
So Bosker asks, or just mentions, so the last time he heard Aristides speak on using Electron was with Angular. They were building a mapping GIS application with Angular to Electron. So
Cool.
I thought that was kind of cool.
Yeah. You can, like I said before, you can even, if anyone is a .NET guy, I still do all my APIs in .NET on the back end, but you can use Blazor. People have done the Blazor where they've done the export for the Blazor, which is WebAssembly, and then imported that into your Electron app, and the packager will package all that stuff up. So technically, you don't have to have HTML and a traditional web app. You can use WebAssembly.
So you've gotten a lot of hard questions. I'm going to ask another hard one.
Sure.
Because I know how much you like that.
Sure. Why not?
I was looking because I'm a big fan of WebAssembly, and I was looking at how web workers work with WebAssembly and how Node's Node's got a sort of a node thread thing as well. How do web workers specifically work with Electron? Because that sort of, it seems like it should work. It's a Chromium instance. You should just be able to create a new web worker and point to a file.
Yeah, and that's what you're really doing. You're just creating a new web worker, pointing it to the code, and then letting it go off, and then waiting for the results to come back.
Electron's just happy to do it. It doesn't care, right?
No, just because so in that case,
it's just delegating to Chromium.
Yeah, it's part of the renderer it's being kicked off by the renderer process, not by the Electron process, which is that main process.
Yeah. And I imagine Node has like worker threads, I think they call it, which is a similar idea. And I imagine that in the main process, that would be where that would happen, right?
Yeah, and you can have that running off of using the node to do threaded processes off of that main process. But the web workers are off of you would run it just like you would in a normal browser web application. It wouldn't have any difference in the way it works.
I think that's the one weird thing about Electron is that you've sort of got a node world and you've got a web world, and then you got the IPC that bridges them together, and things are just subtly different in those two worlds.
Well, and that's
have
where
you found that to
just,
be a gotcha when you're developing on these apps? Because I could see it's like, oh yeah, I'm using web workers here. Oh wait, I can't do that over here. I have to do this other thing over here because it's node now.
Yeah.
Just there's a slightly different metaphor sometimes that would trip you up.
I mean, the big thing is you build your menus. Really, it comes down to 80% of everything that you're interacting between the main IPC and the renderer IPC is through your menu system.
That makes sense.
Because all the menu stuff lives inside the main process, and whenever one of those events get kicked off, it has to send something over to the render process. But sometimes Electron takes care of it, like the open and close DevTools calls. Those are set up to know. Now those are only set up to open the active window that menu is associated with. So if you remember, I had my main window and then I had my setting window, and the menu was the same, but interacting with that menu interacts with the render process that main process is. So that's why you start getting these open windows around, and you need to take care of and remember how to do all the IPC and all the memory constraints too.
Yeah, so it sucks up a bunch of memory and it's hard to think about, so don't do it.
Yeah, it's just, I mean, that's why you just don't, like, if you take a look at most Electron apps, they're
rendered
window.
tabs inside the browser.
Yep, they have one window and they render simulated dialogues and simulated open, like all the typical in a desktop application. Now you do need that for like your open and your system operating system dialogues, like your file explorers and your stuff like that, printer dialogues, but those aren't handled by you as in a render. Those are just handled by the operating system itself. So
my instinct if I was building an Electron app would be to shove everything into one renderer, and then my main process would pretty much just be system event handlers that would call IPC to tell the renderer to do things. And then like all my business logic and everything else would, so 95% of my code would be in the renderer, and then 5% of my code would just be plumbing to map things at the OS level, or occasionally calls from the renderer to the OS level to get it to do something like pop up a system level dialog that says, you know, general protection fault or something, right?
Yeah, exactly. So
okay, I want to make sure I'm thinking about architecting this correctly, given how it works. You know.
Yeah. I mean, that
sure.
Yep. Go ahead.
I'm pretty sure you can also bundle web extensions in an Electron app, and that's how VS Code works with their plugin system. And the way that web extensions also work in Chrome, is that they use this IPC to communicate between kind of Windows and a web extension. So that pattern is pretty familiar to me. Yeah.
The other nice thing is you can do caching. You can leverage the Chrome cache to do cache within your within your web application. So if like if you call a REST API and your Chrome is smart enough to know to cache that return that HTTP response, whatever's coming back in the body, that will also be done in the in your Electron app because it is Chromium. So you can leverage the Chromium cache to do some interesting things also.
Cool. Are there any other questions? Okay, well, you want to stop sharing your screen then, Chris?
Yep.
I will give us a nice little outro here. Let me see what we look like on stream at the moment. It's just the three of us who have our cameras on or on Twitch. Hey, John, say hi to the internet. So, well, everyone, thanks for attending this evening.
Sorry, my mute was on.
Oh, no problem. Yeah, I probably should go to the speaker view anyhow. It'll look better for the recording here. I can cut all this crap out in editing, and then no one will know it was here, right? So, everyone that is on Twitch, thanks for watching. Bhaskar says hi.
Thanks, Bhaskar.
And yeah. Thanks for a great talk, Chris. Electron is really cool tech. It's not the newest, shiniest thing, but it's still super, super relevant.
And there are some newer things out there, but Electron's, I mean, it's mature. So
Yes.
so it's hard to say. I mean, 3-4 years ago it wasn't mature, but now it's pretty mature. It's and as long as you know how to use it correctly, you can do good things with it.
Absolutely. So thanks again for giving the talk. Let's give Chris a nice virtual round of applause.
Thank you.
Yay.
Thank you, guys. I appreciate everyone kind of listening to me. And like I said, thank you for being my guinea pig to kind of knock the dust off of this talk again. So
Thank you, Chris.
Cool. Thanks.
thanks, guys. Hopefully I'll see you guys sometime in the near future in person.